Alright, so section 2.5, matrix factorizations. So in this section we're going to talk about how we can factor matrices. In particular, we're going to look at LU factorizations. But before we do that, let's just remind ourselves about elementary matrices. So let's think about row operations in the matrix. So we could multiply row I by a scalar A. And the matrix has A in the II position and ones down the diagonal, zeros everywhere else. Okay, so that matrix is going to multiply a row by A, row I by A. What other row operations do we have? We could switch row I and J. And so to accomplish that, we switch row I and J in the identity matrix. And if we multiply that matrix by our matrix A, that'll switch rows I and J in our matrix A. The last row operation we look at is replacement. We can replace row I with row I plus a multiple of row J. And so the matrix that does that has an A in the IJ position, ones on the diagonal, and zeros everywhere else. Now these are the ones that we're going to focus on to find our LU factorization. Okay. So to find the LU decomposition of a matrix A, we want to do some row reductions on A to reduce A to an echelon matrix U, keeping track of the elementary matrices used to do that. So if En through E1 are the elementary matrices that we used, starting with E1 and working backwards. Whoops, that's really thick. Then En times En minus 1 all the way to E1 times A gives us U. So if I want to find L, I just need to multiply by the inverse of all of these matrices. And so A looks like E1 inverse, E2 inverse, En inverse times U. So L is the product of those inverses. All right, so that's going to be our method for finding L. And for our purposes, we're going to assume that the only row operations we need are these replacement row operations. Okay. So let's look at an example. Let's find an LU factorization of the matrix A, given here. Okay. So the first row operation we want to do is to eliminate the 1 here in the 2, 1 position. So what would I do to do that? Well, I want to replace row 2 with row 2 minus a half times row 1. So that gives me this matrix. And the elementary matrix that accomplishes that has a negative 1/2 in the 2, 1 position, ones down the diagonal, and zeros everywhere else. Okay, the next thing I want to do is eliminate the 1 here in the 3, 2 position. So I want row 3 to be replaced by negative 2/3 row 2 plus row 3. And this is what we get. So what's the elementary matrix that accomplishes this? Well, it has ones down the diagonals and negative 2/3 in the 3, 2 position. Okay, so we're going to call this one on the left E21 and this one E32 because those are the positions where we've got something that's not 0 and not 1. And now this matrix here is RU, right? This is in echelon form. So A looks like E32 times E21 times A gives us U. So A is going to be E21 inverse, E32 inverse times U. Okay, so we just need to find what this is. And this is actually easy to find. If I want to find the inverse of these matrices, I just replace my A here with negative A. All right. So again, this is what we have. So here's the inverse of those two matrices. And so if I multiply them, this is what I get. Alright, so there's my answer, and you can check if you multiply these two matrices together, that does in fact give you A back. So again, L is this matrix in blue, and U is the matrix here in black. Read the examples in this section carefully, and as always, please email me with questions or talk to me in class.